Hi everyone, welcome back to YouTube classes. It's Divya here with class 8 physics. So we were on the question answers of your fourth chapter, that is energy, and we have completed the question answer part. Hope you all have completed with that and hope you all are safe too. Okay, now today in our class we are going to start with the numericals. So when you write the numericals, don't write the answers alone. You have to write the question and then only write the answers. Now coming to the first question, a force of 30 Newton acts on a body and moves it through a distance of 5 meter up in the direction of force. Calculate the work done by the force. So this is a direct question. Force is given 30 Newton, distance is given 5 meter, and just you have to calculate the work done. You're already learning the equation. Work done is equal to force into displacement. Force is given, displacement is given. Both are in standard units also, so you can directly multiply and find out the answer. Now when you come to the question number 2. A man lifts a mass of 20 kg to a height of 2.5 meter. Assuming that the force of gravity on 1 kilogram mass is 10 Newton, find the work done by the man. Now here mass is given 20 kilogram, height is given 22.5 meter, and force of gravity on a mass of 1 kilogram is equal to 10 Newton, means for conversion only it is given. Now force of gravity on a mass of 20 kilogram, see for 1 kilogram if it is 10 Newton, for 20 kilogram it will be 20 into 10, isn't it? So total force will be 20 Newton, or simply you can say force if it is given in terms of mass, F is equal to mg. Okay, if mass is only given, F is equal to mg, and g value is actually 9.8 meter per second square, but here in question it is given to take it, round it off and take it as 10, so you can multiply it with 10. Now you are having force F value, you are having, then height means the distance or displacement, that is also given 2.5 meter. So this S is here, it is in terms of height, so you can write it as H also, no issue. Now work done is equal to force into displacement, you can calculate it. Okay. Now coming to question number 3. A body when acted upon by a force of 10 kilogram force moves to a distance zero point 0.5 meter in the direction of force. Find the work done by force. Here also take 1 kgf is equal to 10 Newton. Now here again force is given 10 kilogram force. So in terms of Newton when you convert it, so 1 kilogram it is 10 Newton. So for 10 kgf it will be 10 into 10, 100 Newton. That is what is given in the question here. And then displacement, S is given 0.5 meter. You have to calculate the work done. Okay. So when it is in the direction of force itself, force will be equal to, no need to write that also. You can write it as work done is equal to force into displacement. This is also going to be a direct question. Now when you come to question number 4, two bodies of same masses are placed at a height of h and 2h. Compare their gravitational potential energy. See here the question is for comparing. So as I told you earlier also, whenever you are having comparing questions, automatically you will be having two cases like this, isn't it? Two different heights are here. So maybe some other cases, maybe two different other quantities will be there. So accordingly, you are, whenever you are having comparing set of questions, you have to take the ratio between the two. Or else in some cases, you will be having questions for what is the increase in value or decrease in value or change in value. Okay, so in such questions, you are going to take the difference, that is final value minus your initial value. Okay, so these 2 points you have to remember whenever in numericals you are having questions like compare the values, you are going to take the ratio, find the values separately and you are going to take the ratio. And in some cases if you are having questions to find out the increase in value or decrease in value or change in values, These values may be any quantity like your gravitational potential energy or kinetic energy or whatever it is according to the question. If it is going to be increasing, decreasing, or change in values, you have to take the difference. That is always final value minus the initial value. Okay, now let us come to the question. Now here two different cases for height are given. You have to compare the potential energy. So here what you are going to do is you are going to find the potential energy. You are going to find it, you write it with u. So u1 you will be taking equation, you are having m g h. Okay, so since it is going to be the same masses, mass is going to be the same given in the question, no need to take m1 m2. G is going to be a constant. For h1 it is going to be h. So u1 you are having this equation. Now u2 what you are having, m g into, instead of h it is going to be 2h for second case. Now what you have to do, you have to take the ratio between the two. So mg and mg will get cancelled, h and h will get cancelled, 1 by 2 is remaining. Or when you compare the values, you will be having 1 is to 2. 1 by 2, when you compare as a ratio, you will write it as 1 is to 2. So that is all with your question number 4. Now coming to question number 5. Find the gravitational potential energy of 2.5 kilogram mass kept at a height of 15 meter above the ground. Force of gravity on mass 1 kilogram is going to be 10 Newton. This should be capital N. Now mass is given, height is given. It is a direct question. U is equal to mgh. You can apply the value and find it out. Okay. So nothing in that. It is a direct question only. Now when you come to the question number 6, the gravitational potential energy stored in a box of 150 kilogram force is 1.5 into 10 raised to 4. This is not 104. You can see the textbook, it is going to be 10 raised to 4 joule. Find the height of box. Now here what is given? See, you are having the equation u is equal to mgh. Okay. So what is given? U is given, M is given, G value is given. You have to find out the height. So height will be equal to U by mass into G. Okay. So all these values are given. Just you can put and calculate it. Got it? So this is your question number 6. Now coming to your question number 7. The potential energy of a mass or body of mass 0.5 kilogram increases by 100 joule when it is taken to the top of a tower from ground. If force of gravity on 1 kilogram is 10 Newton, what is the height of tower? Okay. Now what is given here? See, you can cut this, no need to write this. What is given there? Potential energy, you know, it is going to be mgh. Now in the question, m is given, potential energy is given, g value is given. So like your previous question, you just have to find out h is equal to u upon mg. So u is given, m is given, g is given. See, this is like a previous question only. No, see now this first sentence, no need to write it. The remaining only is required. That is by printing mistake. Okay. Now coming to question number 8. A body of mass 60 kilogram is moving with a speed of 50 meter per second. Find its kinetic energy. Now what is given? This is also a direct question. Mass is given, speed v is given. You have to find out kinetic energy. So kinetic energy equation, kinetic energy is equal to half mv square, isn't it? So mass is given, v is given, so v square you have to take. Just substitute the values and calculate. You will get the answer for your question number 8. Now coming to question number 9. A truck of mass 1000 kilogram increases its speed from 36 km per hour to 72 km per hour. Find the increase in kinetic energy. See, here the question is to find the increase in kinetic energy. So the same truck is having mass is there. So two values for your speed is there. final value is there, initial value is there. So I told you, whenever you are having questions like increase in values, you have to take the difference, isn't it? Now here what you are going to do, you will be having two kinetic energies, isn't it? So ke1 you will find out with 30. See, one thing here, it is in kilometer per hour. You have to convert it to meter per second first. How will you convert to meter per second? Multiply it with 5 by 18, so you will get it in meter per second. Now after that, kinetic energy equation you are having, kinetic energy is equal to half mv square. So here you can take it, initial value is also there, final value is also there. So ke1 you can take it as u1 u square, and ke2 you can take it as half m v square. Okay, and then take the difference between that. See, when you come to here, it is given all together it is given on the same question. No need to do like that. See, till here you can do it like that, that is initial speed. This conversion you can do final speed also. After that, instead of finding the work done, what you can do is you can find the initial kinetic energy, that is half m u square first. Then you go for finding half m v square, and after that with the values you take the difference between the two. So that will be easy for you, so that you will get the increase in kinetic energy. Okay, now this power of engine is not needed, leave it. Now coming to question number 10. A car is moving with a speed of 15 km per hour, and another identical car is moving with a speed of 30 km per hour. Compare their kinetic energy. Here it is not increase in kinetic energy, it is to compare. So both the values you are going to take the ratio. Find out the kinetic energy first and then take the ratio. So kinetic, since that car is going to be identical, mass is going to be the same. So increase in kinetic energy ke1 will be equal to, what will be the value? See, here also it is in kilometer per hour. If you want, you can convert to meter per second first and then do it, so that you will get the answer in meter. Okay, or in joule. So whatever kinetic energy 1 you can calculate, K2 you can calculate, take the ratio, you will get the value. Okay, so that is so similar to what you have already done. So when you compare it, you will be getting like this. It is going to be 1:4. Next question, a pump rises water by spending 4 into 10 raised to 5 joule. It is not 105, it is 10 raised to 5 joule of energy in 10 seconds. Find the power of pump. So here energy is given, time is given. You have to calculate power. Power is equal to work upon time or energy upon time. It's a direct question. You can just substitute the values and find the answer. Now when you come to question number 12, see, it takes 20 seconds for a girl to climb stairs, and B will take 15 seconds for the same job. You have to compare the work done and power spent by them. See, both are going to do the same work, isn't it? So the ratio of work done will be same only, so that you are having it to be, since they are going to do the same work, ratio will be 1:1 only. Now power you have to find for the first girl, that is power 1, work done upon time taken by the first girl is going to be, so work done you can take it as W itself. Okay, because both are having the same work, or one also you can use, no issue. So 2 times are there, just take that ratio, you will get the answer for ratio. Okay, so with this you are coming to the end of your chapter number 4, energy. Now with this your half yearly portions are also complete your work in your copy also. Make sure no pending work is also there. Okay, so you can start revising for your half yearly exams. All the portions are completed now for your half yearly. So with this we are winding up. Thank you children, take care, bye bye.